In this video, you're going to learn how to graph quadratic functions, also known as parabolas. We're going to go through all these different types, and then at the end of this video, we're going to have a little quiz of 4 questions that you can practice figuring out what type of type that you're given and how to get a good sketch of the graph and how to label some of the key features of that graph. So let's dive into this video. This is designed to be a complete guide, and let's go ahead and take some notes as you're going through. So the first thing we want to review is the parent function, which is this y equals x squared function. We know it's a quadratic because it's a second degree function here where you have that 2 in the exponent position. And so what we're going to do is we're going to make a table of values, -2, -1, 0, 1, 2, and we're going to plug these in for x right here. So a -2 squared, which is a -2 times a -2, that comes out to +4. A -1 squared is -1 times -1, which is 1. 0 squared, 0 times 0 is 0. 1 squared, 1 times 1 is 1. 2 squared, 2 times 2 is 4. Now, if we plot these coordinates on our graph, let's see what this looks like. So left 2, up 4. Left 1, up 1. 0, 0, 1, 1, 2, 4. We get this nice U-shaped graph, which we call a parabola. Now, the key features of this graph are this point right here where it bends. That's referred to as the vertex. There's the line that divides the parabola in half right here on the y-axis in this case. That's called our axis of symmetry. In this case, it's the line x equals 0. Remember, x equals lines are vertical lines. Our domain is going to be all real numbers because the graph goes to the left and the right forever and ever. Remember, domain is what the x values can be, so all reals. And then the range, that's what the y values can be. In this case, the y's are 0 or higher, so we could say y is greater than or equal to 0. Sometimes they'll also ask you about where is the graph increasing and decreasing. See how when you read from left to right, it's going down and then it goes up? So we could say it's decreasing when x is left of 0, meaning less than 0. So I'll say decreasing when x is less than 0, and increasing when it's to the right of 0, when x is greater than 0. Now, we don't want to make this equal to 0 because that's where it's changing direction, that's where it's bending. And they'll also oftentimes ask you, does the graph have a maximum or a minimum? Now, this graph has a minimum, and that minimum value would be 0. That's how low it goes. That's the y-coordinate. It doesn't have a maximum because the graph keeps going up forever and ever towards infinity. So this is what's referred to as our parent function, y equals x squared. But now we're going to look at some of these other types here, starting with y equals ax squared. So what do you think this a value, this coefficient in front of the x squared, does to this parent function right here? Well, it's basically going to be a stretch, a shrink, or a reflection. So what I mean by that is if this number is bigger than 1, it's going to be a vertical stretch. If it's between 0 and 1, it's going to be a vertical shrink. And if this number is negative, it's going to reflect it over the x-axis, making this graph here open downward like that. So what you can do is you can start working with the same table that we used in the first problem here, but we're going to be multiplying everything by 1/2. So the y values by 1/2 would give us 2, 1/2, 0, 1/2, and 2. Let's plot these points now on our graph. So -2, up 2, -1, up 1/2, 0, 0, 1/2, and 2 is at 2. So what happens is you can see it's what we call a vertical shrink. It's like you're squeezing this towards the x-axis, which makes the graph wider. Okay. Now, if we were to look at letter B here, 2x squared, because this number is bigger than 1, right, it's going to be a vertical stretch by a factor of 2. So I'm going to multiply these y coordinates by 2, which is going to give us 8. Let's see, it's going to give us 2, 0, 2, and 8. I'm going to plot these points in these two columns. So -2, 8 would be, let's see, 2, 3, 4, 5, 6, 7, 8. -1, 2 is going to put us right here, 0, 0, 1, 2, and 2, 8, right about there. See how much narrower this graph is? And that's because we're basically pulling on it. That's a vertical stretch by a factor of 2. So this is our parent graph. We're stretching it vertically. And then lastly, for letter C, see this negative, that's going to reflect the graph over the x-axis, making it open down. And the 3, since it's bigger than 1, is going to be a vertical stretch, meaning the graph's going to be very narrow, even narrower than this one. So let's go ahead and put that in this column here. So 4 times negative 3 would be negative 12. 1 times negative 3 is negative 3. 0 times 0, okay, 0. And then 1 times negative 3 is negative 3. And 4 times negative 3 is negative 12. So we're going to graph these two columns. So negative 2, negative 12 would be left 2, down 12. Negative 1, negative 3 right here. 0, 0, 1, negative 3, 2, negative 12 down here. And again, you can see it's opening downward. It's being stretched vertically. One note I want to mention here is that when I say that the number is bigger than 1 or between 0 and 1, I'm really just talking about the absolute value. So like if I take this a, the absolute value of a, this is positive 3, which is greater than 1, which means it's a stretch. All the negative is really telling us is that it reflects it over the x-axis. So that's this form here, y equals ax squared. Now let's look at this one, y equals ax squared plus c. Okay, number 3, we're going to graph this one, y equals 2x squared plus 3. And notice that it's in this form, y equals ax squared plus c. So what does the c do to the graph? Well, that's going to shift the graph up and down in the y direction. So if it's plus 5, it would go up 5. If it's minus 5, it would go down 5. So what that's going to do is, remember our parent function, remember how the vertex where it bends was right at the origin, 0, 0? Now that vertex is going to be at 0, 3. So what I'm going to do is I'm going to plot 0, 3 here on my graph, and I'm going to put the vertex in the middle of my table. Now, why am I putting it in the middle? Because the parabola is symmetric about this axis of symmetry, which goes right through the vertex, it's going to be the same on both sides. So it's going to save us a little bit of work when we're calculating some of our y values for our table. So I'll show you what I mean. So what I'm going to do is I'm going to pick some points on either side of 0 here. I'm going to pick negative 1, that's 1 to the left, positive 1, that's 1 to the right. Or negative 2, that's 2 units to the left of the vertex, 2 units to the right, that's positive 2. Now let's go ahead and plug some of these values in. So if I put 1 in, for x, 1 squared is 1 times 1, which is 1, times 2 is 2, plus 3 is 5. But because this is 5, it's going to be the same on the other side because it's just like you're folding over that axis of symmetry. It's going to have the same y value. If I put 2 in, 2 squared is 4, times 2 is 8, plus 3 is 11. This will also be 11. Okay, so now let's go ahead and plot these points. We've got negative 1, 1, 2, 3, 4, 5 right here. Positive 1, 5. We could do 2, 11, which is kind of going off the graph a little bit. Negative 2, also positive 11. So this graph looks something like this. You don't want to make it a sharp corner like a V. That's more like an absolute value graph. You want to round it out. That's a U-shaped graph, a parabola. But notice what happened. We have a vertical stretch by a factor of 2. That's making the graph narrower because it's going up faster. And then we're picking up the graph and we're shifting it up 3 units. So that's why our vertex is right here. Now let's go through those key features of the graph. Vertex, we've said 0, 3. Axis of symmetry, this dashed or dotted line here that goes right through the vertex, that's the line x equals 0. Remember, x equals lines are vertical lines. Domain, that's saying what can the x values be? That's going to be all real numbers. Remember, the graph goes gradually to the left, gradually to the right. The range, what can the y values be? 3 or higher. So I would say the y values are greater than or equal to 3. Does this graph have a maximum or a minimum? Minimum, okay, and that minimum is equal to 3. Doesn't have a maximum, so it keeps going up. And then where is it increasing? Well, again, it's like reading a book from left to right. This is kind of going down, sort of like a negative slope. You could say, okay, it's decreasing when x is less than 0, and this is decreasing, and it's increasing when x is greater than 0. See, as you go to the right, it's going up, up, up. If you read it this way, it's going to be flipped. So you want to make sure you're reading from left to right, just like what you did when you were thinking about the slope of a line. Although this isn't really going at a constant rate of change, but it is going down, so decreasing. And then also remember, don't include this point equal to, because that's where it changes direction. So, okay, so that's ax squared plus c. Now this one, y equals ax squared plus bx plus c. Again, you can recognize the form. You can see x squared and an x to the first term. And if there's not a c value, you could think of that as 0. But in this case, we do have a c value. There's a form that you're going to want to add to your notes, and that's this guy right here, x equals negative b over 2a. This allows us to find the axis of symmetry, okay, the line that divides the parabola in half, and it's also the x-coordinate of the vertex. So let's do that. So in this case, a is 1, b is negative 2, c is negative 4. Let's just write that down, a, b, c. So x equals the opposite of b. See, negative b is the opposite of b. So opposite of negative 2 would be positive 2, or you can think of it as negative 1 times negative 2 is positive 2, divided by 2 times a, which is 2 times 1. 2 divided by 2 is equal to 1. That's the x-coordinate of our vertex. It's also the axis of symmetry right here at x equals 1. Now, if we plug that 1 back into our equation for x, we can solve for the y-coordinate of the vertex. So let's go ahead and do that. So it'll be 1 squared minus 2 times 1 minus 4. So this comes out to 1 minus 2 minus 4, which is, let's see, negative 1 minus 4 is negative 5. That's the y-coordinate of our vertex. Let's plot that. 1, 2, 3, 4, 5. It would be right here. Okay, now we're going to pick some points on either side of the vertex because we know it's symmetric. It means it's going to be the same on both sides. So I'm going to pick 1 less than 1, which is 0, 1 greater than 1, which is 2, 2 less than 1, which is negative 1, 2 greater than 1, which is 3. See how I'm doing that? Adding 1, subtracting 1, adding 2, subtracting 2. If we plug 0 in for x, 0 to squared is going to be 0, times 1 is 0, 2 times 0 is 0, 0 minus 0 is 0, minus 4 is negative 4. So that means these are going to be the same, both at negative 4. So let's plot that. 1, 2, 3, let's see, 1, 2, 3, 4. Same on the other side of the axis of symmetry. And then if we plug in, let's say 3 squared is 9, times 1 is 9, 2 times 3 is 6. So this comes out to 9 minus 10, which is negative 1. So these are going to be the same, both negative 1. So that's going to put us at, let's see here, negative 1 would be right here. Oops, a little bit higher, right about here, and right about here. Okay, so our graph looks something like that, roughly. Okay, so what do you think on this one? Does it have a maximum or a minimum? Minimum, see it has a low point. What is the minimum? Negative 5. So let's write that down. Minimum equals negative 5. Domain, all real numbers. Range, y is greater than or equal to negative 5. Let's see what else. Axis of symmetry we said is x equals 1. Increasing and decreasing. So it's decreasing, meaning going down when x is less than 1. Increasing when x is greater than 1. And you got it. So let's take a look at the next form, which is this form here called the vertex form. Okay, for number 5, we've got y equals negative 1/3 times the quantity x minus 2 squared plus 1. Again, this is called the vertex form, and the reason they call it the vertex form is because h comma k is the vertex. One thing you want to remember, and you might want to make a note of this, is that whatever is grouped with the x here, that's going to have the opposite effect on the graph. What I mean by that is, see this minus 2? That's actually going to shift it positive 2 to the right. If this was x plus 2, it would shift it negative 2 to the left. So just remember, whatever is grouped with the x has like the opposite effect. So in this case, our vertex is going to be at right 2, up 1, right here. Now in our table, we can put that vertex in the middle again, 2, 1, and pick some points on either side because we know it's symmetric. So it saves us a little bit of work. So I'm going to make this 1 and 3, 0 and 4. If I plug 1 in for x, 1 minus 2 is negative 1. Negative 1 squared is 1. Times negative 1/3 is negative 1/3. Plus 2 is 2/3. So these are both going to be 2/3. If I plug in 0, 0 minus 2 is negative 2. Negative 2 squared is 4. Times negative 1/3 is negative 4/3. Plus 1 is negative 1/3. Okay, now one thing you want to make careful, a lot of times students make a mistake, is they'll just start calculating from left to right. You want to make sure you do the PEMDAS, so parentheses, then exponents, then multiplication, then addition, subtraction last. Some students will multiply and then square, and you're going to get a different answer. So you want to make sure you follow that order of operations. So plotting these points, we've got, let's see, 1, 2/3, that's going to be just right about here. And 0, negative 1/3 is going to be right about here and right about here. So you can see this graph is kind of wide, right? And that's because the 1/3 is a vertical shrink, which is like making it wider. And then the negative is reflecting it, it's making it open down. And then the 2 is shifting it right 2 up 1. So that's our graph right there. So key features, vertex is at, we said 2, 1. This is actually a maximum, see, top of the hill, okay? So we'll say max, and how high does it go? It goes up to a height of a y value of 1. Okay, so you could say max is 1 or y equals 1. The axis of symmetry, that's the line that divides the parabola in half. That's going to be this line right here. It goes right through the vertex. That's the line x equals 2. And the domain and range, we know domain for these parabolas we've been working with is always all reals. The range, though, what can the y value be? Here the y's are 1 or lower. See, it's 1 is the highest or lower, so we say y is less than or equal to 1. Increasing, decreasing. Now this is a little bit different. Notice that as we read from left to right, it's going up, 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 and then down, down, down. So it's increasing when x is to the left of 2. So we'll say increasing when x is less than 2, decreasing when x is greater than 2 or to the right of 2. Again, you want to make sure you do it when you're reading from left to right. If you go the other way, it's going to be reversed. Okay, so that was a good one. Now, number 6, our last form we're going to talk about in this video is what's referred to as the intercept form. Why do they call it the intercept form? Because when you look at these groups here in this like factored form, that's how you can recognize it. By setting these factors equal to 0, you can find the x-intercepts, thus the intercept form. So if we set x minus 1 equal to 0, you can see x equals 1, it's going to cross the x-axis right here at 1. If we set this factor to 0, x plus 3 equals 0, you can see that x is coming out to negative 3. That's the other x-intercept. Now, remember how we said parabolas, they're symmetric, okay? So what we can do is we can find the halfway point between these two x-intercepts to find our axis of symmetry. One way to do that is to average these numbers. You can add them up and divide by 2. So that comes out to negative 2 divided by 2 is negative 1. Or you might be saying, Mario, can't I just count towards the middle? Yeah, you can do that too. Sometimes it comes out to a fraction though, which that's when you might want to use this averaging formula, the midpoint formula. So that's our axis of symmetry, x equals negative 1. Now by plugging the negative 1 back in for x, we can find the y coordinate of the vertex. Remember, the vertex is always on that axis of symmetry. So let's go ahead and plug in negative 1 for x. That's going to give us y equals 2. Negative 1 minus 1 is negative 2. Negative 1 plus 3 is positive 2. That multiplies to 2 times negative 2 is negative 4 times 2 is negative 8. Make sure you don't add by mistake. And so that means our vertex here is going to be at negative 1, negative 8, which is, let's see, 1, 2, 3, 4, 5, 6, 7, 8, right about there. Now, if you want to plot additional points, you can. A key point might be this y-intercept right here, where it crosses the y-axis. You could put 0 in for x. That would come out to, let's see, 0 minus 1 is negative 1. 0 plus 3 is positive 3. Negative 2 times 3 is negative 6. That would be, let's see, right here. And I can reflect that over the axis of symmetry, 1 unit to the right, 1 unit to the left, just folding it over. Now we can get a good sketch of our parabola. Again, make it a U-shaped graph, kind of round it out at the bottom. You don't want it too sharp of a corner there. Okay, key features of this graph. We've already got some of them. The axis of symmetry. We've got our vertex. Is this a maximum or a minimum? It's a minimum. It's like a low point, so we would say minimum, and that's at negative 8. And then we'd say, let's see, domain and range. Domain is all real numbers. Remember, domain is what the x values can be. This goes to the left and the right forever and ever. The range are the y values. And in this case, the y values are going to be at negative 8 or higher. So we'll say y is greater than or equal to negative 8. And then where is it increasing, decreasing? Increasing when you're to the right of negative 1. So when x is greater than negative 1. Decreasing when x is to the left of negative 1. One mistake that students sometimes make is they'll say, well, Mario, why aren't we saying like -8? Like, why isn't it increasing like over here, like when you're greater than -8? Well, we're basically saying for what x values are the y values increasing or the y values decreasing? So for what x values does that occur? And again, remember, it's when you're reading it from left to right, just like a book in English, right? Okay, so now what we're going to do is we're going to quiz you and test you. So test what you've learned so far. Put yourself to the test by doing 4 examples, okay? It's going to be one of these 4 types. I'm going to jumble them up for you. Let's see if we can dive into that quiz now. Okay, here's your 4 quiz problems. Question 1, question 2, question 3, question 4. See if you can graph these. See if you can answer the questions. What's the domain? What's the range? Where's the vertex? Does the graph have a maximum? Does it have a minimum? Where is it increasing? Where is it decreasing? Let's see if we can start with this first one. Go ahead and pause the video. I'm going to go ahead and solve it right now, but pause it and try it on your own first. You might want to try and do all 4 of them first and then check them. But for this first one, I'm looking at this form and I'm saying to myself, Mario, what kind of a form is that? Well, it looks like this form here, y equals ax squared plus bx plus c. How do I find the vertex? I have to use that formula, -b over 2a. Remember, it goes a, b, c. So the opposite of b is -8 over 2 times a. 2 times -2 is -4. -8 divided by -4 is 2. That tells me that the x-coordinate of my vertex is 2. My axis of symmetry is also at x equals 2, okay? And by plugging the 2 back in for x, I can find the y-coordinate of the vertex. So let's go ahead and do that. So 2 squared is 4, times -2 is -8. Remember the PEMDAS, plus 16 plus 1. That's +8 plus 1 is 9. That's the y-coordinate of our vertex. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 is way up there, right? Okay, now what we can do, we can pick some points on either side of that vertex, because remember, it's symmetric. So if I go 1 lower, 1 higher, 2 lower, 2 higher. If I plug 1 in, let's see what that gives us. 1 squared is 1, times -2 is -2, plus 8 times 1 is 8, plus 1, that's 9 minus 2 is 7. So both of these are 7. That's going to put us right here and here. And if I put 0 in, this is going to be 0. 0 plus 1 is 1. So that's going to put us right here and right here. Okay, so now we have a pretty good sketch of our graph. Let's answer the questions. We've got our axis of symmetry already. We've got our vertex already, which we said was at 2, 9. We have our domain, which we know is all real numbers because it goes to the left and right forever and ever. The range is going to be what the y values can be. 9's the highest or lower, so y is less than or equal to 9. It's increasing as we read from left to right when the graph is to the left of 2. See, it's going up. So the increasing when x is less than 2, decreasing when x is greater than 2. Okay, let's go to question number 2 now. When I look at this equation, what did you do for this one? Y equals negative times x minus 1 times x plus 5 looks a lot like this intercept form. See, it's like the factored form. How do I get a good sketch of that graph? Well, I can set these groups or factors equal to 0. So if I say, x minus 1 equals 0, x plus 5 equals 0, add 1 to both sides, subtract 5 from both sides. So x equals 1 and x equals -5, those are going to be our x-intercepts. Now to find the axis of symmetry, it's going to be halfway between those values. So what I can do is I can add them together and divide by 2. So that's -4 divided by 2, which is -2. Right here, that's our axis of symmetry. You can also count towards the middle. See, 1, 2, 3, 1, 2, 3. It's the same on both sides. To find the y-coordinate of the vertex, which lies on that axis of symmetry, we can plug -2 back in for x here. So let's do that. Y equals -1 times -2 minus 1 is -3 times -2 plus 5, which is +3. That comes out to 3 times 3, which is 9. So our vertex here is going to be at -2, 1, 2, 3, 4, 5, 6, 7, 8, 9, right here. Okay, let's write that down. So -2, 9. Now you can plot some additional points, but I have a pretty good feel for what the graph looks like. A key point might be this y-intercept right here. We could put 0 in for x. That's going to be, let's see, negative 0 minus 1 is negative 1, and 0 plus 5 is 5. That's going to come out to positive 5 right here, and I can take the mirror image across that axis of symmetry to get a good sketch of our graph. Okay, so now let's answer the key questions. We've already answered some. Axis of symmetry, x equals negative 2. Vertex, negative 2, 9. Does it have a maximum or a minimum? Maximum, see a high point, okay, and the maximum value is going to be at this y-coordinate of the vertex, so maximum equals 9. Domain, all real numbers. Range, that's what the y values can be, are going to be 9 or lower, so we'll say y is less than or equal to 9. Increasing, that's where it's going up, okay, as you read from left to right, and that occurs when x is less than negative 2. Decreasing, that occurs when x is greater than or to the right of negative 2. And you've got the key features of this graph. So let's go over the last two quiz questions and then we'll wrap up this video. Okay, before we go through these last two questions, if you like the way that I explain things and you've been following my videos for a while and you want to go deeper into Algebra 1 or Algebra 2/College Algebra, I've got links to my video courses for sale in the description below. Students write to me and they tell me, they've used the courses to help them get a good score in their class, or maybe they use it to do some independent study and pass out of a class, or maybe they're preparing to go back to school and they're taking a placement test. All different sorts of reasons, just refreshing, etc. Those courses will take you step by step through Algebra 1 or Algebra 2/College Algebra, oftentimes referred to by different names, but they're going to go through those key concepts. So check out those videos for sale, the courses in the description below. But let's go through number 3 now. So this one, when I look at this equation, what does it look like? It looks like this one right here, the vertex form. So what's great about this is we know that the vertex is going to be at positive 3. Remember, it's the opposite of what's in parentheses here. And negative 4, that's the same. So that's the vertex. So 3, 1, 2, 3, 4, right about there. Axis of symmetry always goes right through that vertex. So we'll say axis of symmetry, x equals 3. Okay. Got our vertex. And then now we can pick some points on either side to get a good sketch. So let's pick maybe 2 and 4, 1 and 5. So let's say if I put 2 in, 2 minus 3 is negative 1. Negative 1 squared is 1, times 4 is 4, minus 4 is 0. So that means this is also 0. So let's plot that. So 2, 0, 4, 0. If we put 1 in, 1 minus 3 is negative 2. Negative 2 squared is positive 4. Times 4 is 16. Minus 4 is 12. That's way up here. Kind of goes off our graph a little bit. So I think we've got a pretty good sketch right there. Now notice it's very narrow. That's because the a value is 4. It was stretching it by a factor of 4 vertically. Let's go over the key features of this graph. We did axis of symmetry. We did our vertex, which is 3, negative 4. Does it have a maximum or a minimum? Looks like it has a low point, a minimum. And what is that minimum value? It's at the y-coordinate of the vertex, negative 4. That's how low it goes. Domain we know is all real numbers. Range is going to be what the y values can be, which in this case, y is going to be greater than or equal to negative 4. Okay, and then where is it increasing and decreasing? So as we read from left to right, it's increasing when x is to the right of 3. Okay, and where is it decreasing? As we read from left to right, that's going to be when x is to the left of 3. And you've got the key features of that graph. So last problem, before I do this one, if you've already bought my courses or you feel like you don't need my courses, but you say, Mario, I would really like to support all this work you put into this Mario's Math Tutoring YouTube channel. How can I do that? Join the channel. There's a join button if you're looking on a desktop, instead of a mobile, but desktop. Join. It's like a few dollars a month and it helps support the content that I put up here. So I really appreciate the members that have done that. So last question, when we look at this one here, what form is it in? Looks like this ax squared plus c form. Now what does the c do? It shifts the graph up and down. In this case, negative 6 means it shifts it down 6. It's not moving left or right. So the vertex here is going to be at 0, negative 6. Let's just write that down, 0, negative 6. Axis of symmetry goes right through that vertex, that's the line x equals 0. Remember, vertical lines are x equals lines. We'll pick some points on either side of the vertex of the axis of symmetry, and let's see what this comes out to. So 1 squared is 1, times 3 is 3, minus 6 is negative 3. So let's plot that. And if we put in 2, we get 2 squared is 4, times 3 is 12, minus 6 is 6. Let's plot that. 1, 2, 3, 4, 5, 6. Mirror image across right about here. You can see this is stretched quite a bit because that a value is 3. So vertical stretch by a factor of 3. This is shifting it down 6. Let's answer some of those key questions about this graph. Domain, all reals, right? Because it goes left and right forever and ever. Range, what can the y values be? Greater than or equal to negative 6. Maximum or minimum? Looks like we have a minimum, and that minimum is negative 6, the y-coordinate of the vertex. Where is it increasing and decreasing? Well, it's increasing when x is greater than 0. Where is it decreasing? That's where x is to the left of 0. And you got it. Let me know in the comments if you were able to get all 4 of these questions right. The next step, sometimes people have a good grasp of these different forms. There's other forms that involve the focus and the directrix. And if you're studying that as well, follow me over to that video right there. I'll put a link to it, and we'll dive deeper into quadratics and parabolas. I'll see you there.